Imagine you are at a music festival where songs from all genres are playing at the same time. Rock, jazz, EDM, and classical, all mixed together. Chaos, right? Now what if we had a way to group similar songs together so each genre played is in its own space? Well, in machine learning, K-means clustering does exactly that, but for data, and in this video, we'll break it down, step by step, with an engaging real-world example. By the end, you'll not only understand K-means, you'll see it in action and even implement it yourself. Let's start with the basics. K-means clustering is an unsupervised learning algorithm that groups similar data points into clusters. It's like sorting your playlist automatically based on song similarities. But how does it actually work? Let's understand it step by step. Step 1, we decide how many clusters we want. Let's say 3. Step 2, the algorithm assigns each data point to the nearest centroid. Step 3, it updates the centroids based on the average position of the points in each group. Step 4, it repeats this process until the clusters stop changing. And there you have it, data neatly grouped into clusters. All right, but what's happening behind the scenes? The K-means algorithm works through an iterative process. It randomly selects key points as initial cluster centers. Then it assigns every data point to the closest cluster center. Now, it recalculates the cluster centers based on the average position of the points in each cluster. Steps 2 and 3 repeats itself until the clusters stabilize, meaning they stop changing. This is why K-means is so efficient. It quickly finds patterns in data without supervision. So, when should you use K-means? Here are some key scenarios. First, when you have unlabeled data and need to find hidden patterns. Second, when you need to segment customers based on behaviors or preferences. Next, when working with large datasets where computational efficiency matters. And when clustering continuous numerical data like customer spending or geographic locations. However, K-means isn't perfect. It struggles with non-spherical clusters and requires choosing the right number of clusters beforehand. Now let's look at a real-world application. K-means clustering is everywhere. It's used in customer segmentation to group shoppers based on their buying habits, in image compression to reduce colors, and even in anomaly detection for cybersecurity. But today, we'll see it in action with something fun, clustering different types of customers based on their spending behavior. Let's get coding. We have a data set of customers with their annual income and spending score. We'll use K-means to group them into different spending categories. Step 1, import necessary libraries and load data. We import pandas for handling data, matplotlib for visualization, and K-means from sklearn for clustering. Step 2, we will generate synthetic customer data. First, we will write x, dash. We use x to store the generated data points and dash as a placeholder to ignore the second returned value, which contains the true cluster labels. Since K-means is an unsupervised algorithm, we don't need these labels, so using dash keeps the code clean and focused only on the data we need. We begin by generating synthetic customer data using make blobs, which creates 300 random data points grouped into 4 clusters. The cluster STD equal to 1.05 parameter controls how spread out the points are, while random state equal to 42 ensures reproducibility. The dataset contains 2-dimensional data x, which we plot using plt.scatter as shown. This visualization allows us to see the raw data before clustering, helping us understand the distribution of points before applying K-means. Now in step 3, we apply K-means clustering. We apply K-means clustering by first initializing the model with K-means. Here in clusters equal to 4 specifies the number of groups we want. The fitX function then trains the model by finding patterns in our dataset. Once trained, labels equal to K-means labels assigns each data point to a cluster, effectively grouping similar points together. Finally, centroids equal to Q-means.clusterCenters extracts the coordinates of the cluster centers, which represent the average position of all points within each group. This step finalizes the clustering process, allowing us to analyze and visualize the grouped data. Now in last step, we visualize the clusters. In this step, we plot the cluster data using plt.scatter as shown. This colors each point according to its assigned cluster using the labels array from K-means. The CMAP equal to Viridis parameter applies a color gradient to differentiate clusters visually, while S equal to 50 controls the marker size, and alpha equal to 0.6 adds transparency for better visibility. Next, we overlay the cluster centroids using plt.scatter as shown. Here, the centroids are marked with a red XA, making them stand out. The S equal to 200 makes them larger for emphasis, and the label equal to centroids ensures they are included in the legend. Here, a legend in a plot is used to describe the elements within the visualization. Finally, we set the plot title with plt.title. Then we add a legend using plt.legend and display the visualization with plt.show. This final plot clearly illustrates how the data has been grouped into clusters and where the centroids are positioned. Take a few minutes and understand the clustering to get a better idea of what we have learned today. Let's recap what we learned today. K-means clustering is an unsupervised algorithm that groups similar data points into clusters. It follows an iterative process to refine clusters based on data similarities. It is used in customer segmentation, image compression, anomaly detection. And we saw it in action by clustering customer spending behaviors. Now it's your turn. Try running this on your own dataset and share your results in the comments. If you found this helpful, hit that like button, subscribe for more machine learning tutorials, and I'll see you in the next one.